Hello student, welcome back. I am Professor Pratik Sathav from Parvati College of Engineering, Bagoli, Pune. Today we have to discuss about the transformation in B Chem subject. Transformation. In last lecture we have discussed of transformation, basic concept of transformation. Now we have to study of formulation in transformation. Formulation. Okay. In any two-dimensional space. Okay. In any two-dimensional space, we have here in image there have one 2D space in which point P is a coordinate of xy and it is transformed to point P dash is a x dash y dash. Okay. Two-dimensional space 2D, point P having x comma y, its coordinates of point P is transferred to point P dash, coordinates is x dash y dash. Okay, P is the original point, it is shifted or transformed to new location. P dash is the x dash y dash. Then if you write a P in matrix formation, then it's a P is equal to x y. Okay, and P dash, then it's a x dash y dash. For finding the new coordinates of P, means finding the new coordinates of P dash, you require to formula, and for that formula you have to formulate this. Formulation means you can find out the formula for calculating the coordinates of P dash is a x dash y dash. If we consider point P is shifted in x direction by Tx, okay, in x direction by Tx, and in y direction it's Ty, okay, in x direction is a Tx, in y direction it's a Ty, okay, it's a shifting of that point. Okay, then Tx and Ty included. Tx in x direction, in y direction is the Ty. It's called a transformation matrix. It's called a transformation matrix. Then for finding the value of x dash y dash, then the finding the value for x dash y dash is equal to transformation matrix into the x and y. Then you will get the value of x dash y dash. This is the formulation of transformation. Formulation of transformation means any transformation. In any transformation, transformation having 5 types: rotation, scaling, mirror. In any transformation, transformation matrix is there, and multiplication of original matrices with the transformation matrices, you get the value for the new coordinates. Okay. Next, in transformation, first point is translation. Okay, first point is, first transformation is translation. Okay, in figure you get the what is meant by translation. Point your line P1 P2 is translated to new location P1 dash P2 dash. Original line is P1 P2, translate to new location P1 dash P2 dash. Okay, if it is a translation, then point P1 is x1 y1, P2 is x2 y2. Then is translate to new location. It's a P1 dash is x1 dash y1 dash, and P2 dash is x2 dash y2 dash. Okay, p1 dash is p2 dash. Okay, if it is a translate, this line is translate by a distance. In x direction it is a tx, in y direction it is a ty. It is a translation value for this transformation. Okay, in x direction it is a tx, in y direction it is a ty. If we consider in 2D matrix, we consider the point P, x and y is translated in this line. Point P, x, y is translated to new coordinates. So P dash is the x dash, y dash. Then new coordinates of P dash, is equal to translation matrix plus original P matrix. Okay, translation matrix plus original P matrix. Then it's again x dash, y dash is equal to px, py plus x and y. Similarly for p1 dash it is, for p1 dash it is x1 dash, y1 dash is equal to tx, ty, x1, y1. Similarly for p2, x2 dash, y2 dash is equal to tx, ty, x2, y2. Okay, these are the new coordinates for this line p1 dash, p2 dash. Okay, we can go for next. Transformation, it's a rotation. Second type is rotation. Okay, in figure you see that the rotation having divided into 2 points. First one is rotation of point, means point P is rotated with the reference of origin to the new point P dash, and secondly it's a rotation of line. First one is rotation of point, second one is rotation of line. In this rotation, that figure, r is the constant distance from O, from origin point. Okay, from O, r is the constant distance. Then pi is the original position angle with the horizontal axis, is the x-axis. Original positional angle with x-axis, means horizontal. Okay, then theta is the new rotational angle. Theta is the new rotational angle in counterclockwise. Clockwise is this direction, it's a clockwise. Counterclockwise is reverse to clock. Okay, it's a counterclockwise direction. Theta, new angle with original point. Or original location in counterclockwise direction. Okay, counterclockwise direction, CCD means counterclockwise direction. Okay, it's a rotational basic. Okay, then rotational matrices is R is cos theta, okay, minus sin theta, then sin theta and cos theta. Okay, it's a rotational matrix. For finding the new coordinates of P dash, it's a x dash, y dash. For finding the, we have a rotational matrix of cos theta, minus sin theta, cos theta. Okay, go for next. Third type of transformation is the scaling. Okay, third type of transformation. In figure, you have to see that there is the original triangle P1, P2, P3 is scaled to P1 dash, P2 dash, P3 dash. Okay, original triangle is P1, P2, P3 is scaled to P1 dash, P2 dash, P3 dash. Okay, if we consider the scaling factor in x direction is a Sx. Scaling factor in x direction. Similarly, xy, Sy is a scaling factor in y direction. Scaling factor in y direction. Okay, scaling factor in x direction is Sx. In y direction is Sy. Then the new coordinates of point P1. Original coordinates of point P1 is x1, y1. Okay. The new coordinates of P1, it's a P1 dash is x1 dash, y1 dash. Okay. It's x1 dash is equal to Sx into x1. And y1 dash is xy into y1. If this value you can transform into the matrices, then scaling matrix S is Sx 0, 0, Sy. Scaling matrix S is Sx 0, 0, Sy. It's a scaling matrix. If scaling matrix is uniform, then uniform means Sx is equal to Sy. Scaling in both directions is same. Then it's again converted into Sx 0, 0, Sx. Because Sx is equal to Sy. It's a uniform scaling. If it is a uniform scaling, scaling is in uniform. Uniform means same in both directions. Okay, go for next.